This example gives you, it actually says to explain the photoelectric effect, light can be considered as consisting of tiny bundles of energy, and those bundles of energy, as we know already, are called photons. First part there, sketch a graph to show the relationship between photon energy and frequency. Well, we know that the energy that a photon has is equal to hf. H is a constant, so we can really say that energy is directly proportional to frequency. So we know that direct proportion gives us a straight line through the origin. So your graph is going to look something like that. B, photons of frequency 6.1 times 10 to the 14 hertz. There's a piece of information there. That's going to tell you how much energy the photons that are coming in here have. This releases photoelectrons. That's just the electrons that are kicked out by each photon and start to fly away. It's just a fancy name for the electrons that are given out from the surface of the material. The maximum kinetic energy of any of these electrons is 6 times 10 to the negative 20 joules. Calculate the work function of the metal. Well, you've got frequency times 10 to the 14 hertz, and you've also got the kinetic energy, the maximum kinetic energy that they can have, which is 6 times 10 to the negative 20 joules. That's enough for you to be able to calculate out what the work function is, because the kinetic energy that this electron will have as it is ejected from the surface is going to be equal to the energy that the photon has in the first place, which is directly proportional to its frequency, minus the work function. So whatever energy it gives up to the material to eject that. So the maximum kinetic energy goes on this side, 6 times 10 to the negative 20. The energy the photon has is equivalent to hf. If you know the frequency, then you can calculate what the energy is. 6.63 times 10 to the negative 34 is Planck's constant, and that's multiplied by the frequency here of 6.1 times 10 to the 14. That's going to be minus the work function here. If you then multiply this value out, you get 4.0443. I'm not rounding up at this stage, I'm going to do that at the end. And then to figure out what omega naught is, it's going to be this value minus this value. Not the other way around, because that's going to give you a negative number. No negative numbers here. Your final answer will be 3.44 times 10 to the negative 19 joules. If you've got a negative number there, that's wrong physics. Remember that something that's times 10 to the negative 19 is a bigger number than times 10 to the negative 20. C, the irradiance due to these photons on the surface of the metal is now reduced. So irradiance goes down, less photons, that means less photons in the surface. So instead of 2 here, there might be just 1. Explain why the maximum kinetic energy of each photoelectron is unchanged. That's going to be for about 2 marks. So you're looking for quite a long sort of point here. What determines the kinetic energy of any photoelectron is the energy that the photon has minus the work function. Now, in this case, the material hasn't changed. It's the same metal, so this work function is going to be exactly the same. This energy of the photon, that's hf, so it's determined by Planck's constant and by the frequency. Frequency has not been changed, so kinetic energy is unchanged. So you're looking at the equation, using your magical arrows, and then using that to power your explanation. So you would say something like the frequency of the radiation has not changed, so the energy the photon has does not change. The material has not changed, so the work function does not change. And given that the kinetic energy is the difference between those two, then the kinetic energy will also be unchanged.